Welcome to the Fast Mode podcast series. I'm Tara Neil, and with me today is Ali Shaikh, Chief Product Officer at Graphiant. Graphiant is a Silicon Valley based provider of a private next generation network as a service NAS. Graphiant's NAS solution provides connectivity between the enterprise WAN, hybrid cloud, network edge, customers and partners, and combines performance, security, agility, and affordability to enable network architects to build enterprise-grade networks at the speed of business. Ali is responsible for the strategic direction for Graphiant, technical alliances, and driving the product roadmap. Ali joins us as part of our exclusive editorial segment on generative AI for network management. Welcome, Ali. Great to have you on today's episode.
Thank you for having me. I'm really excited to be here.
Okay, let's start. Can you explain what data in motion is? Why is it the most vulnerable to cyber attacks?
So when we think about data, we know that we often think about data processing, data storage, and typically when we think about data in motion, we are really referring to the network that transports all of the data that moves around. Now, historically, that has always been an attack vector for, when you think about credit card transactions, when you think about personal information, people have tried different methods of attacks, whether it's denial of service, whether it's man in the middle, because it's a perfect opportunity to capture as much data as possible. Now, what's happened with AI in particular is that the sheer volume of data is so much larger that now the data in motion space, the network, is even more lucrative to attack, because if it has any vulnerabilities, you can siphon pretty much anything you want, from people's information even to the data sets that will be used to train AI models. And that makes things very, very dangerous. It raises the risk, it raises the threat profile so much for our data networks. And this is why, rather than just thinking of the network as plumbing, we really have to think of it as the place where data is in motion, and we really should safeguard it from all the possible new avenues of attack.
Okay, so talking about cyber attacks, right? What type of attacks do you see are most prevalent, especially when it comes to data in motion?
What we typically see, I think you've got the standard styles of attacks where you'll have man-in-the-middle style attacks in particular to siphon data. You'll even see attempts to social engineer access to infrastructure, whether there's compromised passwords on routers in the middle, whether it's route hijacking by injecting artificial routes to capture the path and redirect traffic down a direction it shouldn't go, or even force it to connect to servers that it shouldn't be connecting to, especially with people using so many services on the internet. The most significant thing that we're seeing, though, in the last couple of years is a lot of these attacks are now directly targeted at the telco infrastructure, right? From the AT&Ts, the Verizons, the T-Mobiles, they're the ones who are getting the attacks the most, because if you can get into the telco environment, you can basically get into everyone. Because if you have the routers in between captured, you can siphon everyone's data. And those are the things that have really raised the worry that we should all have. I mean, even just late last year, CISA, the U.S. agency that warns about cybersecurity issues, they basically said, look, a lot of the telco networks have been breached. So use better encryption, use better networking technology to protect your data in motion.
So yeah, you mentioned about AI, and how the use of AI or the prevalence of AI actually increases the amount of data that's being transported across our networks. So and we see that moving forward, AI and generative AI is gaining a lot of traction. So, how does the use of these technologies impact the sensitivity of data in motion? And we have also heard the term AI network being used in this context. So, maybe you can share a little about this.
Oh, certainly. So when you think about what our AI trajectory looks like, I mean, just across the world, the rate at which the technology is advancing, we're going to go from AI to generative AI, and then we're going to end up with agentic AI before who knows at what point in time, AGI manifests. But at each step, the data that is generated, consumed, transported is going to go exponentially higher. So when you think about just between AI and generative AI, you had all of this material that is, on the internet in the public domain that was siphoned up, used to train models, and then it started to generate altogether new content. But that data is just that's in the public domain. The amount of data that's in the private domain, the banks, the manufacturers, the intellectual property that is not on the public internet, is in a very large quantity, and that is now starting to be trained on these LLMs and to start transporting it around between the various clouds and the data centers to start generating new things. The impact this means that the generative AI space will drive in the business realm is that the data that you typically would just park in a storage space in a data lake somewhere is now going to move around, which means the opportunity for someone to compromise your network and harvest this data just so that they can process it later or do whatever they want with it later is so much higher. So our profile as people that run and build networks, it's an altogether new space when we think about what AI is going to do. And that, I think, leads us into what will be these networks that we build for AI, the AI network as it's going to be. This is, I suppose, a broad term about what we think about networking as it evolves. And what we really need to think about is, in the simplest terms, in the past, we used to have very classical client-server models. You had someone that was going to consume an application, but the application itself lived somewhere else. That was true for your mobile apps. That was true for pretty much every application that you used, from a SaaS point of view. In the AI world, that's not really the case. In the AI world, the data could be anywhere. The processing could be anywhere because you have to think about where the GPU clusters are available, where the power is cheapest, how efficiently you can move the data to that point for processing. So at the end of the day, what an AI network means is this is even more peer-to-peer than we thought. And this isn't just client-server where data is in one bulky place. Data in very large quantities is moving east, west, north, south, in all directions. And the network has to adapt to this AI model of consuming, transporting, and processing data.
So, do you see threat actors targeting specifically AI networks?
Absolutely. I think the just from a financial point of view, right, and even from a national security point of view, it is so lucrative for bad actors to attack AI networks because there's so much data and they could compromise so many systems that way that there is absolute incentive for bad actors to attack those. It just makes it that much more imperative to secure them. When you think about what's going to happen, I mean, the US government has already started projects, which means military data, sensitive information is being used for processing via AI infrastructure. When you think about banks, they're rolling out AI from as little as, the chat functions that you get in your mobile banking. That's connected to AI now. And you continue to see it spread. That means if you are a malicious entity, whether you're a state bad actor or just, rogue hackers, it is very lucrative to look at the network layer and say, if I know AI data is going over here and I am able to breach this, I have access to all manner of treasures.
And are enterprises aware of this?
I think they are aware, but there's concern about, the rate at which technology is progressing. They're worried about making the right choice. And in large enterprises in particular, as well as government, inertia can be very dangerous, where they're so worried about making the wrong change that they don't make any change. And so they end up lagging behind. So there is generally, I would say, a sense of we need to do something, but we don't know what, and we're too worried about making the wrong decision. I think the mindset also needs to shift around this is uncharted waters. You're going to have to move fast. And if you're slow, well, the rate at which this technological advancement is happening, you may find yourself that inertia is your biggest enemy.
Absolutely. So, looking at Graphian's role in this space, what is your approach to securing data in motion in AI networks? And how do you enable continuous data and risk assurance for enterprises?
For us, it started from a philosophical point of view. When we looked at the telco infrastructures, when we looked at all the different identity providers and things of that nature, we knew that what we didn't want to become was a lucrative target for bad actors, which meant we did not want to be in possession of anyone's data. So if we were to get breached, we could not compromise anyone. And this philosophical value comes from believing in end-to-end encryption, the way Signal and iMessage and WhatsApp have done to just normal communication right over text for people, where we trust in the fact that it's end-to-end encrypted and no one is able to tamper or compromise it in the middle. We took that approach and said, what if we applied it to the entirety of the internet? If we secured it in such a way that the internet backbone did not have IP routes, did not have next hop information, did not have BGP addresses associated to end enterprises, if we hollowed out MPLS VPNs so that all of this state that is built into the telco infrastructure goes away, well, even if then someone breached the telco, they wouldn't find anything. They wouldn't be able to compromise anyone. And that started as our bedrock. Believe in end-to-end confidentiality. So then that gives us a very good way to start. But that by no means is the end of it. How do you make sure that as the data flows through this infrastructure, without being able to look or compromise the actual data, can we get telemetry and process that telemetry to give us intelligence around how is this AI data moving? Is it going from the correct point A to point B? Is it behaving the way it should, in that it is taking the right path, it is touching the correct countries, or if it's bound by certain geographical laws or restrictions, it should not leave those countries. We begin to build a profile around all of the data movement. And so using telemetry, we are able to run threat intelligence. We're able to look at the profile of the data as it moves through the network and speak to what should be happening, what shouldn't be happening, and how to protect against that. So if you think about what we've combined is two elements: guaranteeing end-to-end confidentiality, so no one can compromise the data, not even us, and telemetry to build intelligence around is the behavior across the entire world as this data moves the right behavior.
So you have rightly pointed out, the how crucial visibility is, despite encryption. So you also talked about the end-to-end confidentiality. I'm just intrigued. Like, if you encrypt all the communications, would it also be an avenue for threat actors to inject threats? And you have malicious traffic flowing through the same channel, and you would not be able to, detect that. Is that a challenge?
So that's a very good thing that you've pointed out. There's two elements to this. One is the actual encryption keys and the encryption information is with the end customers themselves, just like when you think about Signal and iMessage and WhatsApp. It's secured down to that level, which means injecting it in the middle would not be possible. So we do not possess the keys, so no one could compromise us to inject bad traffic. That's one part. But the second part, if you were to highlight that if someone was already inside someone's network and was trying to inject bad data, this is where using telemetry and metadata, rather than looking at the payload itself, we are able to profile traffic patterns and give that continuous assurance around, is this the right data? Or does this exhibit behaviors of compromised data patterns? This is where our threat intelligence, where our continuous telemetry and providing risk assurance comes in. We want to find that right balance of profiling using visibility, using metadata to say this looks right, this doesn't look right, and then we can run our own algorithms to analyze and say if this is right or not without compromising the integrity and confidentiality of the end client's data.
Well, that's amazing. Okay, let's just turn this around. You've mentioned about how AI is contributing to the new volumes of traffic that we are seeing on today's networks, specifically IP networks. But at the same time, do you foresee leveraging AI and also generative AI to enhance your solutions? And if yes, how?
So we do, and we already use that ourselves. When you think about what we're describing, is there's a lot of telemetry, and when we talk about providing assurances, we provide assurances around path assurance, around risk assurance. We provide assurances around governance. We help people improve the trust in their network. But a lot of that relies on there's a huge amount of telemetry that is being generated. How do you synthesize that? How do you make sense of it? How do you build different models that say this should be what the behavior is? This should be what the application should be. And these are application patterns going out to the internet that appear to be insecure. This is what you need to do. All of that is built on, AI systems themselves. So a lot of what we do at Graphiant is around how do we take the best of the technology and allow it to amplify our capabilities. So I don't think it's a far into the future. It's already happening where AI is being used in systems. When it comes to generative AI, this is where on the network side we tend to be a little bit more cautious because we're still, trying to make sure that the things that we train and the responses that they provide are actually authentic and accurate. We don't want to run into the trouble of hallucinations where people in the NOC get a bunch of alerts and all of the alerts were fictitious. That would be very painful. No one wants that. So there is a sense within the AI and networking folks around let's make sure we use the models that are least prone to hallucinations, that inject the least amount of noise in the system, and actually help people reduce noise in the system. And then, of course, even when you think about just software in general, the use of Copilot and other things is accelerating. So I don't see this being too far away. I think this is already happening in the industry itself. And at Graphiant, we're big proponents of it. We believe with absolute conviction that this is a transformative moment. I think if we go all the way back to the founding of the company, right at the very beginning, we had said, we made the claim, if an AGI exists out there, if an artificial intelligence has become, self-aware, it will look at network infrastructure and say, this is so old. This is so archaic. And it will look at Graphiant and say, you know what, that makes more sense for an AI-based world.
Wow. Yeah, I think you described it very succinctly, and it's interesting, where you pointed out how we have sometimes people clump together AI and generative AI and not know that how AI enhances our tools, to increase its predictive capabilities. And like you said, it can now look into anomalies, irregularities by just looking at all the patterns from past traffic flows and all that. But then there should be a little bit more caution for generative AI, as you rightfully pointed out about the making sure we handle hallucinations and also remove noise, so that like you said, maintain authenticity of the results. So I think that's a really great answer, and sheds a lot of light on the discussions that we have around AI and generative AI. So I think we learned quite a lot today, and I had just one other thing that we wanted to know. Can we learn a bit more about Graphian's solutions in this aspect?
Absolutely. My recommendation to all would be go to graphiant.com and check out all of the things that we've posted about data assurance, because we really believe that guaranteeing protection of your AI data workloads as they move around the world is going to become more and more critical. So think about your countries, think about national security, think about trust in the network, and you'll want data assurance. Go to graphian.com, check out our white papers, check out our videos, and ask for a demo. See it live, see it play out in front of your eyes how we protect the data as it moves.
Well, thank you, Ali, for joining us. And I think we are at the end of our session, and we're really grateful for the insights, that you have shared on generative AI and also on securing data in motion in next-gen networks. Any last words?
No, I'm really excited for the future is what I will say. I think every year brings new reasons to be excited about where the world is headed, and I'm so grateful that I get to live and work in this space in this time where something so exciting is happening. And thank you for having me on the podcast today. I really appreciate it.
Okay, great. So, to everyone tuning in, thank you guys for listening. And as Ali mentioned, you can learn more about Graphiant and their suite of solutions by visiting www.graphiant.com. And do follow us for more updates and insights as we continue to uncover the latest in technology and telecommunications. See you in our next session.